Today we're here to take you on a journey to Mars. Our team at De Craigie Space Tech consists of Daniel, Civil Engineer, Renee, Electrical Engineer, Jishnu, Mechanical Engineer, and myself, Craig, Mechatronics Engineer.
The challenge is to build a habitat on Mars to support a crew for a total mission duration of 2.6 years. The crew is made up of 6 people consisting of 2 scientists, 2 medical personnel, and 2 technicians of different genders and cultural backgrounds. SpaceX spacecraft will be used to get there and return home again once the mission has been completed.
A Gantt chart was developed to measure progress and ensure that all tasks are completed within the required time frame.
The habitat was designed by utilising the double diamond design process. Each team member submitted design sketches showcasing their individual concept ideas. The habitat design was selected by combining the best concepts of each team member. This enabled the complete habitat to be created.
The team at De Craigie has engineered the best solution for the stakeholder.
Background research was completed to determine user needs, market conditions, technical details, and engineering considerations.
We defined 37 key user needs for our Mars habitat. The main needs are lightweight, a small environmental footprint, food, air and water supply, as well as good designed working and living areas, monitoring and redundancy of all technical services, and preparation for all emergencies. To achieve these needs, the habitat is designed according space standards. It's emission, weight and use optimized. It will get lifetime tested and astronauts will get trained on Earth. Due to the early group funding process and the upsplitted tasks, it was very easy to combine all the different ideas of the engineers, like the power circuit and the chemical process, into one service module, and the different layouts of the Mars habitat to one final Mars habitat in a CAD model. Due to the De Craigie closed loop system, the oxygen generation, the water recycling process, the electrical power system, and as well as the heat generation is combined into one process, that we are getting flexibility and robustness and a buffering system to our Mars habitat. 3 of NASA's nuclear kilopower reactors are enough to produce electricity and heat for the fuel cell and the Mars habitat. As a backup system, De Craigie developed a 10 kilowatt solar foil power plant that rolls out if there's sunlight and rolls in and cleans itself during dust storms.
The development phase in our project commences with a detailed design encompassing meticulous engineering considerations, rigorous engineering analysis. This project has an entire habitat design. Before we send our 6-person crew to Mars, we need to construct the outer shell dome, a process that takes approximately 3 years. In addition, we need to incorporate Dual for supplying melted robots for the constructions of the dome. Here is an overview of the simple technical stages in our construction process. We have done the design for following principles: manufacturing, reliability, assembly, disassembly, and recyclability. Their essential material are following on table. The reason why we have been chosen because corrosion resistance, durability, yield strength, and low embedded energy. The project budget is essential in determining the success of this project. This cost estimation for all materials units with profit, overhead, tax, and contingency. In FMEA, we have identified process function for each potential failure mode, and we have done also recommendation action to lessen the risk priority number in service system. Lastly, FEA is one most essential infrastructure analysis to implement or design before proceeding to implementation. This project will show the static stress, which consists displacement, safety factor, reaction force, strain, stress. The assumptions of load design is 70,000 Newton, that equal to approximately 18,867.93 kg on Mars. Therefore, the simulation design is safe by implementing this project on Mars.
To design a feasible shelter in Mars, we need to think like aliens and gods. The closest approach to build this mindset is by referring to sacred geometry. The simple concept I used here is the division of unity. If we consider a square to be absolute unity, the division and multiplication of unity can be symbolized geometrically. Finally, these squares are reimagined as individual rooms for my shelter, and we have a shelter that can expand or multiply. This is the main living room where all the 6 members can have meetings. This is the area where our scientists can grow hydroponics and survive. This is the area where we can eat in the dining desk. This is the main bedroom for 2 scientists. We have 3 such bedrooms, 2 for each. This is a desk for 2 scientists where they can perform experiments and do their research work. The team at the Craigie Space Tech has engineered the complete solution to survive on Mars and deliver all stakeholder needs.